In this video, we will go through an example using the pixel command. And through this example, you will see some of the power of our new assembler, which you will cover in the next section. So let me bring up the code first of all, and that's our little assembly language code here. Now don't worry if you don't understand it, it will all become clear as you cover the next section on the assembler. So we're going to start off at origin 8000, so that's the start address of our program. Now forget about this just now, and all this will come down to the bottom. Now in the assembly language, I've generated some extra directives for us. So one of them is called the EQU directive, that is just equals. So I've set up 3 of these here, and we've got one of them called graphics card. And graphics card is equal to 0 cross triple F5. So we know that 0 cross triple F5 is the memory mapped IO location for the graphics card 1, which we're going to use for the pixel command. So what we do is we just associate that with the word graphics card. So it means that every time we see the word graphics card, we actually mean this memory location. Now the colour is going to start off at a value of FFFF, which is a value which is white, and the position is going to start off at position 0. Now if you head up here, we can see we've got a loop here. So we've got a begin loop and then a jump to begin. So we're going to continually run through this loop. There's no actual end command here in this one, we're just going to keep running through. Now I'll actually get rid of this because we're not going to use that one for the moment. Now we're going to have the pixel and then graphics card R0, R1. So we're going to print a pixel to the screen. It's going to go to through graphics card 1, which is this address here. The colour is going to be in register R0 and the position will be in register R1. We're then going to go and subtract 100, so that's the literal number 100, from register R0 and put it in register R0. So it means we're going to take 100 away from the colour. So the colour will change. So the next pixel comes along will be a different colour. And then we're going to add 100 onto register R1, store it in register R1. So we're going to take the position of R1, which originally is 0, and we're going to move it 100 locations along. So we move 100 locations and we change the colour by a value of 100. Then we move another 100 locations and change the value by 100. And we just continue doing this to generate a pattern on the screen. And then when we've worked through the subtract and the add, we do the jump, we jump back to the beginning. Okay, so it just runs through this loop. Of course, we have to set up the values initially in register R0 and R1. So in register R0 contains the value colour, which is the value 0 cross FFFF. And the original position in R1 is just position 0. So this is the type of assembly language that we can write up once we've worked through our new assembler in the next section. So if I save this and I can open up the assembler again and I can run through this, and you see it's generated the code, and from that code I can go in and we'll put the program in. And that's us ready to run this up. So we'll put it at full speed and simulate tick enabled. So that's it starting to run up the code now. We have the colour in register R0 and you can see it started at FFFF and it's counting down 100 at a time. And the position started at 0 and it's counting up 100 at a time. and you can see it's starting to put the little dots on the screen. So I'll zoom in just so you can see that a bit closer. Now it's not going to run tremendously quickly. First of all, because obviously it's just a little simulation machine on Logisim, but secondly because as I'm recording this I'm using up my own CPU time, so if I stop recording this it will run maybe 3 or 4 times quicker. But you can see now it's just generating all of these dots on the screen. So I'll pause the video for now, and I'll bring it back in whenever we see the final result. Now I have let that run for a couple of minutes now, and you can see it building up a pattern on the screen. It might not seem like the most exciting output, but if you think back to the beginning of the very first Design a CPU course, we started off with an AND gate and an OR gate and a few other gates. And if you take a look and see how far we've come since that course, we've actually built up quite a lot of functionality. Now another interesting thing that you can do here whenever these simulations are running, you can slow it right down. So you could go to the frequency of say 4 Hz, and then you can drop into each of the blocks and you can see them working. Now the one that you're really going to be interested in here is to check out the working of your graphics card. So you can drop inside and then you can watch as each of the values change. And initially you're going to have this going high, and then we're going to choose this one and then this one here, and then the final value come out. This will go high and this will go high, and we'll have an output appearing here. So you can slow it right down and you can see these individual changes happening, and it helps to get an understanding of how the circuit works, and also it can help you find any small errors that may be occurring that are difficult to see. So that's all for this video. I will be working through periodically and adding in some other videos which will generate some more interesting graphics. Also, whenever you've covered the assembly language programming, you will be able to write some more interesting functions which will do more interesting things on the screen. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.